Namaste to all. Once again, welcome to data structures. So, last class we studied about different operations on linear data structures or arrays. So, in that one, first one is traversal. Traversal means visiting all the nodes exactly once or passing through all the nodes exactly once. Actually, it is possible on arrays only, and some other data structure is not possible to implement this one. So, after traversal, next concept is searching. Searching an element. See, according to our syllabus, there are two types of searching methods. One is linear search and second one is binary search. So, what do you mean by linear search? Linear search is also called as sequential search. So, what do you mean by linear search? See, under linear search, actually searching starting from 0th element to the n minus 1 element. 0th element means I'm referencing its index position 0 to n minus 1. n minus 1 means last element. So, index value starting from 0th element to n minus 1 element or an element whose value equal to the search key, then it will stop the searching process. So, under linear search, so there are some advantages and disadvantages. So, advantages is it is applicable to both sorted or unsorted list. So, we can use linear search for both. In case of sorted list, so searching from starting from 0th element to the element whose value equal to the search key. Or in case of unsorted list means searching from 0th element to the last element, or we can say n minus 1 element. Okay, these are about linear search or advantage of linear search. And second one is disadvantage. So what are the disadvantages of linear search method? Actually there are only one disadvantage, so that is time consuming. So linear search, it will take more time, so it is time consuming. Okay, these are about linear searching method, and just go for this one, algorithm for linear search. So last year you studied about algorithm. So what do you mean by algorithm? Actually algorithm means it's a step-by-step process to solve a problem. There are some steps, so we have to specify its algorithm name and its a step number. Sometimes we need to specify the comments also if it requires. And here algorithm name is linear search, and here array name A, capital A, and number of elements n, and ELE is the search key. So what do you mean by search key? Search key means element to be searched. Element to be searched. So after this one, so algorithm is very important. Whenever you are writing the examination also, we need to write the algorithm first, algorithm name first. And here consider an array A of n elements. ELE is the search key. That means we have to specify all variable names under this one. And that is just like a comment. And next one is step 1, LOC equal to minus 1. So LOC equal to minus 1 means actually we are initializing a variable. LOC equal to minus 1. So normally whenever we are going to initialize a variable, we are going to start with 0. But according to array concept, 0th location already there. So that's why we have to use LOC equal to minus 1. 0th location already there, so we can't use 0, LOC equal to 0. So that's why I am using LOC equal to minus 1. And next one is we have to implement the traversal. Traversal means just we have to visit all the elements. That is to check whether that particular search key is present or not. If I equal to 0 to n minus 1, that means according to array concept, index value starting from 0 to n minus 1. n minus 1 means last element. So just we are visiting all the nodes. And third step is if A of I equal to ELE. A of I equal to ELE. That means whether the search key is present. If it is true, this condition is true, immediately after this statement we have to implement this. LOC equal to I. Here I is the location. So if A of I equal to ELE, location equal to I. Immediately we have to specify that one. LOC equal to I. So after getting the particular location, that means if it is search key is present, immediately we should come out of this particular loop. So here we are using go to step number 7. Step number 7 means out of this for statement. Step number 7, or in C++ programming language we can use break. So what do you mean by break? Break is to come out of the loop. Break is to come out of the loop. So go to step number 7, and after that we have to use end if, end for. Actually these two are comments. Actually this indicates, end if indicates end of this particular if statement, end for indicates end of this for statement. So next one is step number 7, if LOC is greater than or equal to 0, in any case, if LOC is greater than or equal to 0, greater than 0 means it's okay. That means any location number. Equal to 0 means first location is 0 itself. If search key is present in the first location, so automatically that should be equal to 0. So that's why if LOC is greater than or equal to 0, print LOC. That means just we have to specify the location. Element is found in this location. Next, else if it is not, print element is not found. Next we have to use endif. Endif indicates end of this particular if statement, and then step number 11, stop or end. Okay, these are about algorithm of linear search technique. Okay, let us see how to implement linear search method in C++ programming. So this, write a program to find the location of an element in a list, or we can say in an array. And here hash include iostream.h, hash includes eonio.h, hash include iomanic.h. So these three header files that we need to start any program in C++. See, so first thing is void main. So far we know that. So what is the purpose of using void? Void indicates there is nothing to return. Void indicates that there is nothing to return. That means there is any variable or arguments to pass from that function to any other function. Okay, let it be. See, int a of 30 n. A of 30 means array. N, total number of elements. I is that is to specify the index value. Next, POS, that means position, that is to store the location of that particular search key, whether it is available in that particular array. Next, ELE is the search key or element to be searched. Okay, next one is clear screen. See, normally clear screen, that is to clear the output screen before execution, right? Next, cout, enter number of elements. Here I am reading this one, n. N means total number of elements, n, that must be less than or equal to 30, not more than 30, because actually n means that means we are going to put some limitation. So limitation that should not go beyond this one, 30. So within that one we have to use n. And next, cout, enter the elements. Enter the elements. Here we are going to implement the traversal. These two statements we can say traversal. That means just we are taking all the elements. That means touching all the elements or visiting all the elements exactly once. For I equals 0, I less than n, I plus plus. Here I indicates the index value, or we can say subscript value, and C in A of 5. That means this particular statement that will touch all the elements or visiting all the elements. In case of, in the form of, that means accessing elements. Okay, so next one is enter the search key. Enter the search key means this particular statement C in ELE, that is to read the search key from the user before searching process involves. And after this particular statement, we are going to implement linear search algorithm. So starting from this page, we are applying linear search algorithm. Position equal to -1. According to that one, that algorithm, you are using LOC equal to -1. Next, for I equal to 0, I less than n, I plus plus. And here also we are using traversal, but if ELE equal to A of 5, in any case A of 5, that means we are taking I equal to 0 to n minus 1. So what happens is ELE equal to A of 5. Here I starting from 0 to n minus 1, we are reading each and every element, and in any case ELE equal to A of 5, immediately we have to write position equal to I. Immediately we have to store position equal to I, and we have to use break. Break is to come out of this particular loop for statement. We actually to come out of this for statement, immediately we have to use break statement. And here after this one, after end of this for statement, once if you are able to get the particular search key, then immediately we should come out of that particular loop using break statement. And again, need not to search the elements whether it is available or not. So here, if position is greater than or equal to 0, if position is greater than or equal to 0, cout element found in location LOC element. For example, 5 found in location fourth location. Else, if it is not true, immediately after this one, it will display element is not found. That element is not found. Next, get ch and closed flower parenthesis. hypothesis. Okay, these are about linear search technique. Okay, under linear search, the linear search method, we can depict that one by using these two diagrams. See, just here go through this one. Here search key is equal to 21 and array elements, A of 5 elements are there. So 5 elements are, we can represent like this, 10, 32, 26, 21 and 45. Elements are A of 0, its location is 0 and its value is 10. A of 0 is 10. A of 1 is 32, A of 2 is 26, A of 3 is equal to 21, A of 4 equal to 45. So what happens is, according to algorithm, we have to first location equal to -1 or position equal to -1, and after that we have to use for I equal to 0 to n-1 according to algorithm, for I equal to 0 to n-1, but here we are using 0 to 4. And here we are comparing that one. Here comparison, 21 is compared with 10. So 21 is different from 10. It's not equal. So search key is not equal to the element. 21 is compared with 32. This is not okay. Here also not equal. Here 21 is compared with 26. 21 is compared with 21, and that way. So after comparing this one, 21 is compared with 21 itself. So what happens is, elements are equal, so automatically we have to note its position. Its position is 3, so it will come out of the loop. So no need to execute the last element, or no need to check the last element. And here comparison and position, 21 and 21, position is equal to -1. Initially we are going to initialize that one as -1, and 21 is compared with the 32, so position is equal to -1 itself, and 21 is compared with 26. Here position also -1, 21 equal to 21. Yeah, it's true. So position equal to 3. Okay, these are about linear search method. So overall we can say linear search method result we will get, but under linear search method or sequential search method, it is time consuming. So it is the main disadvantage of linear search method. And advantage is it is applicable to both sorted list or unsorted list. Okay, these are about linear search method. Next concept is, next searching method is binary search technique. So what do you mean by binary search technique? So binary means normally we are using two values, and here also we are going to divide the given list into two lists or two tables, and again we are going to perform the same operation. And here why we need binary search technique? So first thing is, it's very fast and efficient method of searching. Very fast compared to linear search. Binary search is very fast, and second point is, it requires sorted array or sorted list. To implement binary search technique, we need elements or array elements that must be in sorted order. Then only it is possible to use or implement binary search technique. And next one is, it uses divide and conquer method. So what do you mean by divide and conquer method? Actually, repeatedly it will divide the given array or table or list into some other pieces, and according to that one we are perform the searching operation. Okay, these are about binary search technique. So it uses divide and conquer method, and last point is, it divides the given array into two halves. For example, we have list of elements. So first thing is, it divides the given array into two halves, and according to our search element, that is compared with the center element. Okay, these are about binary search technique. Binary search technique, we need elements must be in sorted order. It may be ascending order or descending order for your convenience. So according to our syllabus, we are using ascending order, and here we have a list of elements like this, list of elements, and we have to consider it is beginning and here it is end. Location of the first element is B and location of the last element is E, and here consider array A of n elements, array A of n elements, and then according to binary search algorithm, we have to divide the given array or list of elements into two halves. So just we have to divide and consider this one as middle element. So how to find out this one, middle element? So for example, location of B equal to 0 and location of E equal to 5, that means total 6 elements. B equal to 0 and E equal to 5, so total 0 to 5 means total 6 elements. And how to find the location of middle element? So to find the location of middle element, we can take it like this: m equal to b plus e divided by 2. b plus e divided by 2. So that is to find the location of the center element. So obviously we will get 0 plus 5 divided by 2. So answer is 2.5. But we need integer value. So that's why we need here, we have to implement type conversion. So we can take it as m equal to int of b plus e divided by 2. So what happens is automatically we will get the integer value without including the fractional part. So here answer is 2, middle is equal to 2. In that way we have to implement. Okay, these are about binary search technique. So starting element is b, or we can say beginning, and last element is e. So we have to find center element b plus e divided by 2. So we will get the location of the center element. Suppose if you want to get the value of the center element, we have to use a of m. A of m indicates value of the center element. Suppose if you want to find the value of first element, a of b, value of last element, a of e, in that way we have to use. Okay, let us go to this one, algorithm. How to implement binary search technique. So algorithm name is binary search, array a of n elements, and ELE is a search key. And then immediate after this one, algorithm name, we have to specify all the comments. So what are the things, or what are the variables we are using in this program or in this algorithm. So here set b equal to LB. B means beginning, LB means lower bound. That means index value of the first element. So normally we can use b equal to 0 also allowed. B equal to 0. So location of the first element in any array or 0 based indexing, its value equal to 0. Next, E equal to LB. E equal to UB. UB means upper bound. UB means upper bound. Normally it is equal to n minus 1, where n is the total number of elements. N is the total number of elements. B equal to 0. UB equal to n minus 1. Just go to next statements. While B is less than or equal to E. So we know that B means location of the first element, it is less than or equal to E. E means location of the last element or end element. And here, if this condition is true, so in any case, B is less than E. So what's the purpose of using minus? See, purpose is, sometimes what happens is, actually we are dividing the given array. We are going to divide all the array into two halves. Again we are going to repeatedly divide this array into two halves like this, and after this one again we are dividing. So that is the purpose we are using. While b is less than or equal to e, sometimes what happens is b is equal to e. In some situation what happens is beginning point, end point, and in mid point all are same. So that's why we are using b is less than or equal to e. Next, m equal to int b plus e divided by 2. M equal to int b plus e divided by 2. So that indicates, that means we are going to search the center element or middle element. And here in any case, if ELE is less than a of m, if ELE less than a of m, sorry, it's not less than, it's equal to, if ELE is equal to a of m, location is equal to m. ELE is equal to a of m, location equal to m, and go to step number 4. So go to step number 4 means this one. So just come out of the loop. Okay, if ELE equal to a of m, location equal to m, go to 4. Else, if ELE is not equal to a of m, ELE is not equal to a of m, so what happens is, so three options are there. One is ELE equal to a of m, that means equal or less than or greater than, three options. So if ELE is less than a of m, if ELE means search key is less than a of m, so automatically searching involves in the first half. Searching involves in the first half. To specify that one, B means B equal to m minus 1. B equal to m minus 1. That means beginning equal to m minus 1. So here, else E equal to m plus 1. If it is not there, B equal to m minus 1, else E equal to M plus 1, and here use end of while. End of while. So that indicates end of this while statement. Next, fourth step. If LOC is greater than 0, then print LOC. If it is found, else print search is successful. If LOC is greater than 0, print LOC, else print search is unsuccessful, exit. Okay, these are about algorithm of binary search technique. Let us see how binary search technique works. Say there is a program, write a program to implement binary search technique. Here include iostream.h, void main, next after this one int a of 10 I, that is to specify the index value, n, total number of elements, next m, that is to specify the middle element, next LOC, and LOC, or we can say position. LOC is not necessary now. Next B means location of the starting point, I mean first element. E means location of the last element, and position ELE. C out, enter number of elements, C in n. So we have to read number of elements, n number of elements. Here n means n must be less than or equal to 10. So here what are the limitations given? That should be within that one. N should be less than 10. Here it is 10, so n should be less than 10. Next, see out, enter the elements. Here also we are using traversal. For I equal 0, I less than n, I plus plus, C in a of 5. That means that is to read all the elements. Again we are implementing the traversal. Next, see out, enter the search key. Enter the search key. Search key means element to be searched. And here C in ELE to be searched. Next, we are implementing the binary search algorithm. Here position equal to -1, position equal to -1, or location equal to -1, B equal to 0, 0 means lower bound, in our algorithm it is lower bound, E equal to n minus 1, that is UB, upper bound, last element, I mean location of the last element, B is the location of the first element, E is the location of the last element. And after this, while B is less than or equal to E, B is less than or equal to E, in all the cases B is less than or equal to E only, and here M equal to int B plus E divided by 2. Int means that is to get the integer value only, not floating point. For example, starting point is equal to 0, end point is equal to 5, that means E is equal to 5. So what happens? Automatically answer will be 2.5. Any number divided by 2, odd number divided by 2, that means what happens? Here automatically it will give the floating point value. So to avoid that one, M equal to int, we need this one, so that indicates type conversion, int B plus E divided by 2 if ELE equal to A of n. ELE equal to A of n. M means middle element. In any case, if ELE equal to A of n, so what we have to do? Position is equal to M. Position equal to M. That means we have to initialize the value of position with the value of M. That means we are getting the value of the center element. That means center element is equal to the search key. Then we have to wind up with the searching process or come out of the searching process. So in that case, position is equal to M. Next we have to use break statement. So break statement, that is to come out of the loop. So loop means here while loop is there. So to come out of this while loop, we have to use break statement. So last year you studied that one in first PUC syllabus, computer science syllabus. Break and some other unconditional statements are there. Break, continue, and go to statements, etc. That okay. Here we are using break statement, that is to come out of the loop. Let us see what happens next. Else, if ELE is equal to A of n, if given element is not equal to the center element, so some options are there. Else, if ELE is less than the A of m, that means if given search key is less than the center element, search key is less than the middle element, so what we have to do? Again we have to reallocate the list. How reallocating? Beginning will be 0 only, end is equal to m minus 1, middle minus 1, end is equal to mid minus 1. For example, we have list of elements like this. Here center element. If search key is somewhere here, that is less than the center element. So search key involves in the first half. If search key is greater than the center element or middle element, search key involves in the second half. This one is first half, here it is second half. So that's why we have to use this one. If ELE is less than A of M, then end is equal to mid minus 1. End is equal to mid minus 1. Else, if it is not there, then what happens? Beginning is equal to M plus 1. Beginning is equal to M plus 1. M plus 1. Or end is equal to mid minus 1. End is equal to mid minus 1. Else, beginning equal to M plus 1. Okay, these are about minus H algorithm. Here we are going to come out of the loop, and if so, what happens? If this case is not proper, so again and again it will execute the same set of instructions. Just we are using B is less than E. Again we are using the same set of instructions. Here also, again we are finding the center element, and center element is searched with or compared with the search key. Again we have to go for the same. Again we have to reallocate the location of the first element, location of the last element, and location of the middle element. So this process that will continue like this. If in any case if it is equal to the center element, then only it will come out of this particular looping construct. And if POS means position is greater than or equal to 0, see out position, that is to display, and else see out search is unsuccessful. Okay, these are both binary search technique program. Okay, so next operations on linear data structure is inserting an element. How to insert an element to the list? So according to your syllabus, actually we are going to insert an element to the particular position, but there are different types of inserting an element. We can insert an element to the beginning, we can insert an element to the middle section, or we can insert an element to the end. And here some algorithm is there. One algorithm is there in your syllabus. In that one, we have to insert an element to the proper position. Position should be mentioned by the user itself. So how to insert an element to the list or to the one-dimensional array? So here, how to insert? For example, you can take an array A of 6 elements. 6 elements here, its index value or position value starting from 0